What is model and what is modeling? In a broad sense, a model is an informative representation of some real object. So we take some part of the reality, some real object of the world, and looking at it and start to exploring it and produce some representation of this object. For example, we look at a very big mountain and take plasticine and produce a little model of this big mountain. But now we have it very small in our hand and we can rotate it by different angles and explore it and show to other people the surface of this mountain. We can divide models in two classes. The first class is the physical models. So, as I said, for example, as a plasticine model of a mountain. And on the other hand, there exists abstract or conceptual models. And of course, this is relates to science and philosophy. For example, if we take some mathematical structure, this will be some abstract or conceptual model. Models should not be confused with a theory. The model seeks only a way to represent the reality. The purpose of better understanding or predicting this part of reality. And the theory is more ambitious in that it claims to be an explanation of reality. So the model just say you that this part of reality, it shows you this part of the reality and say that it as it is, okay? And the theory is answer you why these parts of reality have for example, such a structure, why it have this behavior, and so on. The modeling process includes three elements. The first element is researcher itself. The second element is the object of study. And the third element is a model itself. It produced by a researcher, then it explores the object of study. And this model defines or reflects the relationship between the cognizing subject and cognizable object. Models are very good to use for simulations, for direct measurements and experiments. And because it is very impossible or impractical to create an experimental conditions under which scientists can directly measure the result. Of course, when the researcher or subject produce a model, it has some constraints in its sensor system, in its cognitive functions, and that's why every model is some approximation of the real object. We can describe the real object in all the details. So the model is some synthetic objects in our mind. And more than this, they do some abstractions when they model this object, and also they do some they just remove some unnecessary parts. We only focus on some parts of this object according to our goal. So this is why the different models can represent the same object absolutely in different way, because our goals are different, and maybe the angles from which these models created are also different. There is also the notion of the simulation. The simulation is a process of the behavior of the model in some conditions. For example, we can divide simulations into static and dynamic simulation. Static simulation show the information about the system in a some point of time, and the dynamic simulation show how this model show the behavior of the model in some continuous interval of time. We can review some subclass of the models which called scientific model. And this model seeks to represent empirical objects, phenomena, and physical process in a logical and objective way. And the main goal of this model, of the scientific model, is to build the formal system. And this formal system must mimic to the real system, and it must predict the behavior of this system. So if you look here, we have real system which has some objects inside and relations and has causality, and then the scientists look at this real system, it encode it into the formal system, which has some implications. Okay, the causality depends on time, but the implication is just a logical construction, and after that it decodes its true real system and see the correlations, and it tries to make this formal system that it is behavior very close to the real system, and it can predict the real system. Of course, we can provide the visualization of the model. We can create, for example, images, diagrams, or animations to show our model from some point of view.